Hello students, so today we are going to start with our NCERT chapter 8, which is aldehyde, ketone and carboxylic acids. So today is a theory part 1. So the sections which we will cover in today's class is section 8.1 to section 8.1.2. This is the disclaimer. Now, how to prepare for competitive exams. So first of all, you have to read the NCERT. So you will thoroughly cover the NCERT textbook. The NCERT textbook will cover all your basics. Then comes the important reactions and mechanisms. You have to master the key preparation method, which is oxidation, reduction and hydrolysis. So these reactions, they are the building blocks of organic chemistry, which helps you to transform one functional group into another. You have to practice important reactions, which are nucleophilic addition, oxidation, reduction, esterification. You have to understand the reaction mechanisms very clearly. Okay, so understanding the reaction mechanism is essential. Then comes the functional group identification. You should know how to identify aldehyde, ketones, and carboxylic acid. So you should know that how aldehyde looks like, what functional group it contains, or how ketones look like, or how carboxylic acids look like. Next, you should know about the physical properties. You should understand the boiling points, solubility, acidity trends, and their explanations. And for a better understanding of the concept, you need to solve the previous year questions extensively for both JE and NEET. Okay, this helps you to understand the exam pattern and the types of questions which are being asked. So if you practice more and more questions, it will improve your knowledge. Then you should solve the mock test. So mock test is very crucial for improving your accuracy as well as your speed. So you should take mock test, and you should also write short notes. So these short notes are very helpful in summarizing preparation methods, key reaction, test and physical properties for quick revision. So these notes will be your quick reference guide that will help you last minute revision before the exam. Okay, now we will see what is the objective of today's lecture. So after attending this lecture, you will be able to understand the topics which we are going to cover today. So today we are going to see the common and IUPAC names of aldehydes and ketones. So we will see that what the set of rules we follow to name aldehydes and ketones. We will write the structures of the compound which contain carbonyl functional groups like aldehydes and ketones. Now for your reference, I have also mapped the NCERT section which we are going to cover today. So today we will be covering section 8.1, which is nomenclature and structure of aldehyde and ketones. Then we will see section 8.1.1, which is nomenclature. We will see section 8.1.2, which is structure of aldehydes and ketones. And then we will solve an in-text question, which is 8.1. And then we will summarize whatever we have studied in today's lecture. Okay, so let's start with today's lecture. So today we will start with first by carbonyl compounds. So first we will see what are carbonyl compounds or how we define carbonyl compounds. So the organic compounds which contains a carbon oxygen double bond. So if you see over here, this is a carbon oxygen double bond. So such organic compounds are called carbonyl compounds. this C double bond O group is called the carbonyl group. So you will see that this C double bond O group is present in your aldehydes, ketones and carboxylic acids. So if we see about the use of this, we will see that carbonyl compounds, they are not just confined to laboratory. So this is very interesting that they are abundantly found in nature. For instance, they are present in fruits and vegetables, which contribute to their aroma and flavor. And they also play a significant role in animal kingdom, such as in hormones and pheromones. And in addition to plants and animals, the carbonyl compounds, they are also found in microorganisms. So you can see their versatility and the importance of carbonyl compounds in both the natural and industrial contexts. So next we will see some examples. First of all, if we see about vanillin, okay, so vanillin, which gives vanilla its characteristic flavor, it is found in vanilla beans. Next, if we talk about salicylaldehyde, then another example which is found, this is found in meadow sweet. So this compound, that is salicylaldehyde, it is related to salicylic acid, and it is a precursor to the aspirin. Next, if we talk about cinnamaldehyde, then it is extracted from cinnamon. Then it is another carbonyl compound. So it gives cinnamon its distinctive smell and is used in flavoring and as well as in perfumes. So if you look at this examples of carbonyl compound, you see over here, this is the structure of vanillin, and this vanillin is found in vanilla beans. Similarly, this is salicylaldehyde, which is present in meadow sweet, and if you look at this is cinnamaldehyde, okay, which is extracted from cinnamon. So these are some examples of carbonyl compound. So these are used in many food products, pharmaceuticals, adhesives, paints, plastics, as well as in fabrics. So let's now see the types of carbonyl compound. Okay, so first type which we will see is of aldehyde. So first, if we talk about aldehyde, the general formula of aldehyde is RCHO. So this is a general formula how you denote aldehydes. Now this R over here can be either a hydrogen, it can be a aryl, or it can be a alkyl group. Okay, it can be either of the one. So if we talk about the general IUPAC name of aldehydes, the general IUPAC name is alkenyl. Okay, normally we say like it is written as alkene. So the E over here is replaced by Al. So the IUPAC name is alkenyl. Now look at this. This is how aldehydes look like. So general formula is RCHO. So this is a carbonyl group which is present, that is C double bond O. And on one side you have a R group. Okay, and this R group can be either a hydrogen also, it can be a aryl group also, or it can be a alkyl group also. And on one side there is a hydrogen. So one side there is R group and another side there is hydrogen. So this is how a aldehyde looks like. Now if we see the examples, so this are all the examples of formaldehyde. If you look over here, this is the carbonyl group which is present. On one side there is hydrogen and on other side also there is hydrogen. So I said that as this R group can be hydrogen, alkyl or aryl. So over here it is a hydrogen. So the common name of this is formaldehyde. And if you look over here, this is C double bond O. One side you have a CH3 group and other side of carbonyl you have a hydrogen. So this is called as acetaldehyde. And in this over here you can see that you have a C double bond O carbonyl group. One side of the carbonyl group you have an aryl group and other side you have a hydrogen. This is called as benzaldehyde. Okay, we will understand their names their common names as well as their IUPAC names in upcoming slides. So first, just see how this aldehydes look like. So you have a C double bond O. One side it is a R group, which can be hydrogen, aryl or alkyl, and other side you have a hydrogen. Now we will see another type of carbonyl compound, which is ketones. Okay, so earlier we studied about aldehyde. Now we will see about ketones. So the general formula of ketone is R C double bond O R dash. So this is a general formula of ketone. Now R and R dash, they can be alkyl or aryl groups. Okay, it cannot be a hydrogen in case of ketones. So the R group or R dash group, it can either be an alkyl group or an aryl group. R and R dash may or may not be same. So if we talk about this R and R dash, they can be same also. So if they are same, then the ketones, they are symmetrical. And if R and R dash, they are different, then I can say that it is a asymmetrical ketone. So the general IUPAC name of ketones is alkanen, that is alkane plus ONE. So E over here is replaced by ONE in case of ketones. Okay, so this is the general IUPAC name, which is alkanen. Now if you look at this is how a ketone looks like. You have a C double bond O over here, that is the carbonyl group, and one side there is a R group and other side also there is a R group. So that can either be an alkyl group or an aryl group, which may be same or may not be same. That means in case of ketone, the carbonyl group on both sides is connected to carbon. Now if you look the examples of ketones, this is called an acetone. So see over here, this is C double bond O. This side also you have a methyl group and this side also you have a methyl group. So this is acetone. Then this over here, this is a C double bond O group. On this side you see there you have a aryl group. Okay, and this side you have a alkyl group, that is a methyl. So this is acetophenone. So these are the examples of ketones. So next type of carbonyl compound which we will see is carboxylic acids. So let's see about carboxylic acids. So the general formula of carboxylic acid is R C double bond O OH. So that is RCOOH. This is the general formula of carboxylic acid. Now this R, it can either be a hydrogen, aryl or an alkyl group. Okay, it can be either one of them. So the general IUPAC name of carboxylic compound is alkanoic acid. That is, you replace E by OIC. Okay, alkanoic acid. This is the general IUPAC name of carboxylic acids. So this is how a carboxylic acid looks like. This is a carbonyl group. On this side you have a R group, and this R can be a hydrogen also, aryl or alkyl. And on other side of carbonyl you have an OH group. Okay, that is the hydroxyl group. So one side R group, other side hydroxyl group. So this is how a carboxylic acid look like. So if you see the examples of carboxylic acid, this is a methanoic acid. Okay, you see here there is only one carbon atom. So the root word is methane and E is replaced by oic. So this is methanoic acid. Similarly here it is a ethanoic acid. This is C double bond O. On one side you have a methyl group and on other side you have a hydroxyl group. Similarly over here you can see this is C double bond O. One side you have an aryl group and other side you have a hydroxyl group. So this is how the carboxylic acids look like, and these are the examples: methanoic acid, ethanoic acid and benzoic acid. Now next type of carbonyl compound which we will talk about are amides. Okay. So if we talk about amides, then the general formula of amide is RCONH2. Okay. So here in this case also your R group, it can be a hydrogen or aryl or an alkyl group. So the general formula for amide is alkanoamide. Okay, so this is the general IUPAC name, how you write the names of an amide. It is alkanoamide. So this is how amides look like. This is C double bond O. One side you have a R group and other side you have this NH2 group. So this is how a amide looks like. Now let us see some examples of amide. So see over here, this is methenamide. This is C double bond O. One side you have hydrogen, other side you have NH2 group. Similarly, this is ethanamide. You have C double bond O. One side you have an alkyl group, other side you have NH2 group. Similarly, over here, this is a carbonyl group, which is C double bond O. On one side of carbonyl group, you have an aryl group, and on other side you have a NH2 group. So this is the general these are the examples of the amides and how the amides look like. And the general IUPAC name is alkene plus amide, that is alkeneamide. Now the next type of carbonyl compound which we will see is acyl halides. Okay, so these are the next type of compounds which we see. They are called as acyl halides. Okay, so if we talk about acyl halides, then these are derived from carboxylic acids by replacing the hydroxyl group with a halogen atom. Okay, so in carboxylic group it is R, C double bond O, OH. Okay, so in acyl halides what happen? You replace the hydroxyl group with a halogen atom. So the general formula is R C double bond O X over here, and this X over here is a halogen atom, and this R C double bond O is a acyl group. That is why it is called as acyl halide. So this R can be a hydrogen, aryl, or an alkyl group. Okay, it can be either one of them. So X can be a fluorine, chlorine, bromine, or iodine. So as I told you, the X over here, they are halides, and this X can either be a fluorine or it can be chlorine, bromine, or iodine. So the general IUPAC name of acyl halides is alkenyl halide. So this is how you write the IUPAC naming of acyl halides. That is alkenyl halide. So if you see over here, this is how acyl halides look like. You have a carbonyl group which is C double bond O. One side there is a R group that can be a hydrogen, aryl, or alkyl. And on this side there is a halogen which can be fluorine, chlorine, bromine, or iodine. Okay. Now let's see the example. So this is a acyl halide. You see, this is C double bond O. One side you have a hydrogen, other side you have a chlorine. So this is methanoyl chloride. Similarly, look here, this is a carbonyl group, C double bond O. One side you have an alkyl group and other side you have a halogen, which is bromine. So this is ethanoyl bromide. Similarly, look here, this is a carbonyl group. This side you have an aryl group and this side you have a halogen, which is chlorine. So this is benzoyl chloride. Okay, this is how your acyl halides look like. Now comes the next class of carbonyl compound, which is esters. So esters are basically formed from carboxylic acid plus alcohols. Let us see how. So if I talk about esters, then esters, the general formula is R C double bond O OR dash. Okay, so this R and R dash, it can either be an alkyl group or it can be an aryl group. Now this R and R dash may or may not be same. If it is same, then we can say we have a symmetrical ester, and if it is different, then we have an unsymmetrical ester. So the general IUPAC name of ester is alkyl alkonate. Okay, so if I talk about esters, I told you that this is how a ester looks like. This is C double bond O, this is R group over here, and this is OR dash group over here. So it is formed from carboxylic acid plus alcohol. Okay, so this R part, it comes from the acid part, and this R dash part comes from the alcohol part. Okay, so when you name it, like this is alkyl alkonate. So this alkyl part, it comes from the alcohol part, and this alkonate part comes from the acid part. Okay, so if you see the examples, the first example, if you see, this is ethyl butanate. Okay, so this is CH3, CH2, CH2, C double bond O, OC2H5. Okay, so this is ethyl butanate, that is butanoic acid plus ethanol. Similarly, if you look over here, this is ethyl benzoate. So it comes from benzoic acid plus ethanol. Okay, so this comes from carboxylic acid plus alcohols. Okay, so next type of carbonyl compound which we are going to discuss is anhydrides. So anhydrides, when you remove water from 2 carboxylic acid, you get an anhydride. So general formula you see, it is RCOOCOR dash. This is how an anhydride look like. So R and R dash can be hydrogen, aryl or alkyl group. R and R dash may or may not be same. So it can be same also or it can be different also. So the general IUPAC name is alkanoic anhydride. This is how you write the general IUPAC name of anhydrides. So if you look over here, this is acid anhydride. So as I told you, if you remove water from 2 carboxylic acid, you get an acid anhydride. So this is R, C double bond O, O, C double bond O, R dash. So if I see the examples, then this is methanoic anhydride. So this methanoic anhydride is formed from formic acid. Okay, when you remove water from 2 molecules of formic acid, you get methanoic anhydride. Similarly, this is ethanoic anhydride. And this ethanoic anhydride is used in aspirin preparation. Similarly, this is benzoic anhydride. Okay, when you remove water from 2 molecules of benzoic acid, you get a benzoic anhydride. So this was about anhydrides. So these were the different types of carbonyl compounds which we discussed, like aldehyde, ketones, carboxylic acid, acid halides, anhydrides, ester. So you should know how each one of them look like, okay, and what are the general IUPAC name of all these types of carbonyl compounds. Now students, we will look towards the structure of carbonyl compounds. So if you see over here, this is the structure of carbonyl compound. This is C double bond O. So if you see, then this carbonyl compound forms 3 sigma bonds. See, this is carbon. It is over here. It may be connected to an R group or an H group. Okay, it may be connected to a R or a hydrogen. So it forms 2 sigma bonds from here. See, one this sigma bond and one this sigma bond. And there is one this double bond. And double bond consists of 1 sigma bond and 1 pi bond. Okay, so if you count it overall, you see over here 1, 2, 3. So it consists of 3 sigma bonds and 1 pi bond. Okay, so it can form 3 sigma bonds, 1 with oxygen and 2 with other substituents. Okay, so if we talk about the bonding of carbonyl carbon, then this forms 3 sigma bonds, 1 with oxygen and other with 2 substituents, okay, like as we discussed. And it forms 1 pi bond with oxygen. So if you see over here, this oxygen, so it forms 1 pi bond with this oxygen. Now if we talk about this geometry of carbonyl group, then the geometry of carbonyl group is trigonal planar. Okay, that means in this case trigonal planar, everything will be in plane. Okay, imagine just like you have a flat triangle where the carbon is at the center and the substituents are at the corner. So the shape is trigonal planar. Next, if we talk about the hybridization, then the carbonyl carbon, it is sp2 hybridized. Okay, so if I talk about the hybridization of this carbonyl carbon, then it is sp2 hybridized. This means that the carbon atom uses 1 s orbital and 2 p orbital to form the sigma bond, creating a planar structure. Next, if we talk about the bond angle, so if it is trigonal planar, the bond angle is 120 degree between substituents. Okay, so this is 120 degree and this angle is typical for trigonal planar geometry, ensuring that all the substituents over here, they are evenly spaced. So this is the bond angle, which is 120 degree. So if you look at this figure over here, okay, this is the bond angle between substituents. So you see the bond angle over here is 120 degree between the substituents. So this is how a trigonal planar look like. Everything will be in plane, okay. Next we will talk about the electronic character. So first we'll talk about the polarity in the carbonyl group. So the higher Pauling's electronegativity of oxygen compared to the carbon. So we know that in a carbonyl group there is carbon which is double bonded to oxygen, and the carbon, as we compare the electronegativity, then we know that the electronegativity of oxygen is more than the carbon. So the polarity in the carbonyl group, it arises because oxygen is more electronegative than carbon, okay. And I expect that you all know that electronegativity is a measure of an atom's ability to attract and hold on to the electrons. So oxygen being more electronegative, it pulls the electrons towards itself more strongly. So if you see over here, this is a carbonyl group which is C double bond O over here, and oxygen is more electronegative, okay. So the bond between carbon and oxygen is highly polar. This means that the electrons in the bond, they are not shared equally. So if you see over the electronegativity of oxygen is 3.5 and the electronegativity of carbon is 2.5. So you can exactly see that the electronegativity of oxygen is more over here. So the bond between carbon and oxygen is highly polar, okay. So what happens in a polar bond, the carbon bears a partial positive charge. Why? Because the electrons are pulled away from the carbon towards the oxygen, okay, which leaves the carbon electron deficient. So this partial positive charge can make a carbon atom an electrophile, okay. So the carbon atoms bear a partial positive charge, so this carbon atom can behave as an electrophile which can attract nucleophile towards itself. Similarly, if I talk about oxygen, then it bears a partial negative charge, and this is because of the higher electronegativity which allows it to hold on to the electrons more tightly. So this partial negative charge, it can make the oxygen atom behave as a nucleophile, okay. And if it will behave as a nucleophile, meaning it can donate electrons to other atoms or molecules. So if you look at this structure, this is the polarity difference in carbonyl group. This is the oxygen bears a partial negative charge because it is more electronegative and it takes the shared pair of electron towards itself. Similarly, if you see over here, the carbon, it bears a partial positive charge, okay. So this is about the polarity difference in carbonyl group. Now next we will see about this dipole moment. So the carbonyl compounds have a substantial dipole moment, okay. So the dipole moment is a measure of separation of positive and negative charge in a molecule. So we know that in carbonyl compound, our oxygen is more electronegative than the carbon. So it pulls the electrons towards itself, which creates a dipole. So if you look at this example, this is an example of a formaldehyde, and which is an aldehyde. So you see over here, the dipole moment over here is 2.27, okay, because a dipole moment is created because of the electronegativity difference of this oxygen as well as the carbon, okay. So this explains that why they have a higher boiling point than non-polar molecules of similar molecular mass. So if we explain by resonance, so this is involving a neutral A and a dipolar B structure, okay. So this is a neutral structure. If you see, this is C double bond O, which is a carbonyl group. So the neutral structure A shows a typical double bond While you will see the dipolar structure, which is B, it shows a shift of electrons, which create a positive charge on a carbon atom and a negative charge on oxygen. Okay, so this resonance helps explain the reactivity and the properties of carbonyl compounds. So this is a neutral molecule and this is a dipolar one. Now we will talk about the electrophilicity of carbonyl group. So carbonyl carbon is electrophilic. Okay, as I told you that there is a partial positive charge on carbonyl carbon. So the carbonyl carbon is electrophilic, okay, meaning it acts like a magnet for electrons. This happens because we know that oxygen, being more electronegative, pulls away the electrons away from the carbon, okay, which makes it positively charged and eager to bond with electron rich species. Similarly, if I talk about carbonyl oxygen, then it is nucleophilic in nature. Okay, so the oxygen in carbonyl carbon is nucleophilic, means it can donate the electrons. This is because of the high electronegativity, which allows it to hold onto electrons tightly and share with them, which are in need of those electrons. So the carbonyl carbon is electrophilic and the carbonyl oxygen is nucleophilic. So electrophilic means it acts as a Lewis acid, and nucleophilic it acts as a Lewis base, Lewis acid that accepts electrons, as well as Lewis base which can donate the electrons. Okay, so if you look at this structure over here, this is a neutral molecule, and if you see, then this oxygen bears a negative charge and this carbon bears a positive charge. So this is an electrophilic center, or we can call it as Lewis acid. Okay, and this behaves as a nucleophilic center because oxygen has electron density towards itself. Okay, now we will talk about the common names of aldehyde. When in first slide we were discussing about aldehydes, there I told you how aldehydes look like. But how do we write the common names of aldehydes? So first of all, let us see that the aldehydes, they are derived from corresponding carboxylic acids by replacing IC acid with aldehyde. So what happens when you oxidize aldehyde, you get carboxylic acid, okay? And there is a similarity which is present in their name. So what you do, that you replace the IC acid from the corresponding carboxylic acid with aldehyde. Okay, let us see the example, it will be more clear. So this is a carboxylic acid, which is formic acid. See, this is the structure of how a carboxylic acid look like. So there it is a R group, which can be hydrogen or alkyl or aryl group. And on the other side, you have a hydroxyl group, which is OH group. So I told that if you replace this OH with hydrogen, you get an aldehyde, and the name is formaldehyde. So the aldehyde which is formed from the formic acid is formaldehyde. Okay, so from formic acid, the aldehyde which is formed is called formaldehyde. So just see, I've replaced IC over here with aldehyde. So this is formaldehyde. Similarly, if we see about the position of the substituents, then it is indicated by the Greek letters. Now, if you have to tell that which substituent is located at what position, so this is indicated by the Greek letters like alpha, beta, gamma, or delta. So the carbon atom which is directly attached to the aldehyde group is alpha carbon. Okay, so the carbon which is directly attached to aldehyde is alpha carbon. The beta carbon is the second carbon which is next to alpha carbon. So next to alpha carbon is a beta carbon. So the naming system continues following the Greek alphabetical sequence. So the sequence is alpha, beta, gamma, and delta. Let us see the example. So this is an example of bromobutylaldehyde. If you see over here, this is an aldehyde group which is C double bond OH. And I told you that the carbon atom which is directly attached to aldehyde is alpha carbon. So this carbon over here is alpha carbon. And next to alpha carbon, this carbon is a beta carbon. And next to beta carbon, you see there is a gamma. So this is the sequence which we follow. Okay, and if you see at the beta position, a bromine group is attached. So this is beta bromo butyroaldehyde, but because you see 1 2 3 4 4 carbon atoms are there, so the root word for 4 carbon atoms is but. Okay, and if you see over here, then IC over here is replaced by aldehyde. So this is beta bromo butyroaldehyde. Next, if we see, then the simplest aldehyde is formaldehyde. So the formaldehyde, if I say, it is the simplest aldehyde. So this is on both the sides of this carbonyl, this C double bond O or the carbonyl group, you have a hydrogen atom. So this is commonly called as formaldehyde. Now, if we see the other examples, this is acetaldehyde. Okay, so from the acetic acid, which is your carboxylic acid, you get a corresponding aldehyde, which is acetaldehyde. And similarly, from benzoic acid, you get a aldehyde, which is benzaldehyde. Okay, so this is how a benzaldehyde looks like. You have a benzene ring to which this carbonyl group is attached, or this aldehyde group is attached over here. Next, we will talk about the common names of ketones. Okay, so we discussed common names of aldehyde, where the corresponding carboxylic acids by replacing IC acid with aldehyde. Now we will see in the case of ketones. So in ketones, you have to identify the two alkyl or aryl groups which is attached to the carbonyl. So if you see over here, this is a carbonyl group which is C double bond O. Over here, it is a phenyl group which is an aryl group. And over here is a ethyl which is an alkyl group. So first you have to identify the alkyl or aryl groups which are attached to the carbonyl. Similarly, see over here, this is C double bond O. On one side you have a methyl and on other side you have a ethyl. So both sides you have an alkyl group. Okay. Now you write this you write this alkyl or aryl groups according to the alphabetical order, and you add the word ketone at end. So this will be how you will write this name, ethyl phenyl ketone, because E comes first, then P. So it is ethyl phenyl ketone. Similarly, you will see over here it is ethyl methyl ketone. Okay. So if we see further about the common names of ketones, we will list them alphabetically, which is followed by the word ketone. As I told you in previous slide, you will write the alkyl or aryl groups alphabetically and then it is followed by the word ketone. Example, if you see, which we discussed, then if you see over here, the one side you have an methyl group and on this side you have a ethyl group. So E comes first, that is why you write ethyl methyl ketone. So this is how it looks like. This is C double bond O. This side there is methyl group which is CH3 and this side there is an ethyl group which is CH2CH3. So the name is ethyl methyl ketone. Now if I talk about alkyl phenyl ketones, okay. In case of alkyl phenyl ketones, on one side you have an alkyl group and on other side you have a phenyl group. So you determine the specific alkyl group other than the phenyl group which is attached to the carbonyl carbon. So you will determine the specific alkyl group and add the name of acyl group as prefix to the word phenol. Okay. So then you will write the name of acyl group as a prefix and then you will put the word phenol. This is how you name alkyl phenyl ketones. If you look at this example, then you see over here, what is acyl group? It is R C double bond O. So the acyl group over here is acetal. So acetal is the acyl group over here. So first you write the name of acyl group, okay? And then you write the word phenol. So this is acetophenone. This is how you name alkyl phenyl ketones. First you write the name of acyl group and the suffix which we use is phenol. So this is acetophenone. So if we talk about the positions, so the position of substituents, they are again indicated by the Greek letters. Okay, so this is alpha, alpha dash, beta or beta dash. So the carbon atom which is next to the carbonyl group is indicated as alpha or alpha dash. So the carbon which is comes next to the carbonyl group is either alpha or alpha dash. So beta and beta dash carbons, they are next to alpha and alpha dash carbons. So the naming system continues, which follows the Greek alphabetical sequence. So if you look over here, this is a carbonyl group over here, and the carbon which is next to this carbonyl group is alpha carbon. So if this is alpha carbon, then this is alpha dash carbon, because both these groups, they are next to the carbonyl group. So if this is alpha, then this is alpha dash carbon. Similarly, if you look over here, if this is alpha, this is alpha dash, and next to alpha it is beta, and next to alpha dash it is beta dash. So next to alpha this is beta carbon, and next to alpha dash this is beta dash carbon, and next to beta dash carbon there is gamma dash carbon. So this is gamma dash carbon. So if you look over here, students, this is a carbonyl group. So the carbon atom next to the carbonyl group is alpha. So this is alpha and this is alpha dash. Similarly, next to alpha is beta and next to beta is gamma. Now if you have to write that at what position OH group is present or hydroxyl group is present. So you write beta hydroxy ketone, because on beta carbon the OH group is present. So it is beta hydroxy ketone. Similarly, if you see over here, this is a carbonyl group. Next carbon to the carbonyl group is alpha. So if this is alpha, this is alpha dash. This is beta, so this is beta dash. Next to beta is gamma, and next to gamma is delta. Now if you see, there is unsaturation which is present between alpha and beta. Okay, there is this double bond is present. So if I have to write the position of this unsaturation, so this will be alpha beta unsaturated ketone. Now if we talk about the simplest ketone, it is acetone. Simplest aldehyde is formaldehyde. Simplest ketone is acetone, which is CH3, C double bond O, CH3. This is a acetone. On both sides of carbonyl group, you have a methyl group attached. If we see other examples, so if you see these other examples, this is acetophenone. So one side if you have a alkyl group, other side, one group over here if you see is a phenyl group, okay, and the other side if you see it is an alkyl group. So how you write the name of such kinds of ketones, which is alkyl phenyl ketones? First you write the name of acyl group, and then you add the word phenone, or the suffix which you add is phenol. Okay, so over here the acyl group, you see it is acetyl group, so this is acetophenone. Okay, this is propiophenone, and if you see both sides of this, there is a benzene ring or a phenyl is present, so its name is benzophenone. Okay, now we will see the IUPAC nomenclature of aldehydes and ketones. Earlier we discussed the common names. Now when we write the IUPAC name, there is certain set of rules which you need to follow when you write the IUPAC name of aldehydes and ketones. So first you have to identify the longest continuous carbon chain that includes the carbonyl group, which is C double bond O. So first you will see the longest carbon chain. So if you see at this figure, students, so what is the longest carbon chain which you can identify? Can you tell me? So if you see over here, I think this is the longest carbon chain. 1, 2, 3, 4, 5, 6, 7. So this is the longest carbon chain. So starting the number from carbonyl carbon. So you have to start the numbering in such a way that the carbonyl carbon gets the least possible number. So you will start the numbering from this particular carbon. So if you see over here, the numbering will be 1, 2, 3, 4, 5, 6 and 7. Now comes the part of substituents. We have identified the longest carbon chain. Now we will see the substituents which is attached. So prefixed in alphabetical order with position. So if you see over here, on third position a methyl group is attached, and on fourth position a bromo group is attached. So these are the substituents. On third position a methyl group, and on fourth position a bromo group. Now for the alphabetical aldehyde, replace E of the corresponding alkane with Al. I told you that how you write the IUPAC name of aldehyde. The E of alkane is replaced by Al. Okay. So if you write the name of this particular compound, students, you will see that first how many carbon atoms are there? 7. So the root word is heptane and E is replaced by Al. And on fourth position there is bromo, third position there is methyl. So 4 bromo, 3 methyl, heptanal, Al. Okay, so the suffix which we use for aldehyde group is Al. So this is how you will write the name. Since B comes first, then M, so that is why we are writing 4 bromo first. 4 bromo, 3 methyl, heptanal. Now if I talk about aliphatic ketones, then for aliphatic ketones, you have replaced the E of corresponding alkane with ONE, that is 1. Okay, so you replace the E by ONE. So if you see over here, then I said you have to do the numbering in such a way that the carbonyl carbon gets the least possible number. So we'll do numbering from this side, that is 1, 2 and 3. So if you see on carbonyl carbon, a phenyl group is attached. Okay. And how many carbon atoms are there? 1, 2, 3. So the root word will be propane. And E is replaced by ONE. So how you will write the name? 1 phenyl propane 1 on. This 1 denotes the position of the carbonyl group. Since it is at the first position, so this is propane 1 on. So this is how you write for aliphatic ketones. Now for aldehyde group which is attached to a ring. Now if a aldehyde group is attached to a ring, suffix carbaldehyde is added after the full name of cycloalkane. So first you will write the full name of cycloalkane and then you will add the suffix carbaldehyde. And this is for the aldehyde group which is attached to a ring. So if you look over here, then see students, this is a ring to which a aldehyde group is attached, C double bond OH. So how you name this particular compound? So the suffix carbaldehyde is added after the full name of cycloalkane. So what is the name? It is cyclohexane. Hexane, why? Because there are 6 carbon atoms. So cyclohexane carbaldehyde. This is the name of this particular compound. For aromatic aldehydes, named as substituents benzaldehyde or benzene carbaldehyde. So if you see over here, then this is a CHO group or a aldehyde group which is attached to this benzene ring. And at fourth position, you will see a nitro group is also attached. Okay. So the suffix which we can use is benzaldehyde or benzene carbaldehyde. Both of them are absolutely right. You have to name the substituent as benzaldehyde or benzene carbaldehyde. So how you will name it? First we will see the prefix which is 4-nitro. So it can be either 4-nitrobenzaldehyde or it can be 4-nitrobenzene carbaldehyde. Okay, you can write either of the names and both are correct. Now we will see for the compounds containing more than one aldehyde group. So if there are more than one aldehyde group which is there in a compound, how you write the name? So the number the alkyl chain that contains the aldehyde group. So you will number the chain that contains the aldehyde group. And then you will use the suffix carbaldehyde for the aldehyde group. Use multiplicative prefixes like di, tri, etc. to indicate the number of CHO groups. So if 2 CHO groups are present, you will use the word di. If 3 are present, then tri. Okay. So see the example. Indicate the position of CHO group using Arabic numericals before the multiplicative prefix. Now see it will be more clear. If you see at this compound, you have 3 CHO group. Okay, so you have to use the Arabic numericals. So this is, if I'll do the numbering from this side, 1, 2, 3. Then on first carbon, a CHO group is attached. So this is 1 carbaldehyde. Similarly, on second carbon, a CHO group is attached. This is 2 carbaldehyde. Similarly, in third carbon, a CHO group is attached. This is 3 carbaldehyde. Okay. So if you write the name, there are 3 carbon atoms. So the root word is propane. So propane 1, 2, 3 tricarbaldehyde. This is the name of this particular compound. Now we will see for the look at these particular examples. Okay, so these are the common examples of IUPAC names of some aldehydes and ketones. These are the IUPAC names. If you see, this is an aldehyde group. Okay, so in case of aldehyde, the E of an alkane is replaced by Al. Okay, so since there are two carbon atoms, so the root word is eth, so it is ethanol. Similarly, if you'll see, this is an aldehyde group. Okay, if I do the numbering, then 1, 2, 3, 4, 5, 6, 7 carbon atoms. So the root will be hepta, and E is replaced by Al. So this is heptanol. Now look at the substituents. At fourth position, bromine is attached. On third position, methyl is attached. So 4 bromo, 3 methyl heptanol. Similarly, look at this. This is a ketone. Okay. So in ketone, you replace the E of alkane by ONE. Okay. So what will be the name of this? Count the number of carbon atoms. If you see, there are 5 carbon atoms. Okay. So you'll do the numbering in such a way that the carbonyl carbon gets the least number. So this will be start from 1, 2, 3, 4, 5. So on third position, a methyl group is attached. So 3 methyl cyclopentanone. Okay. Similarly, look at this. In this ring, aldehyde group is attached. Okay. So in case you write the name of full cycloalkane, which is cyclohexane, and you use the suffix carbaldehyde. So this is cyclohexane carbaldehyde. Okay. Similarly, look over here. This is also an aldehyde. How many carbon atoms? 5. I'll do the numbering from this side. 1, 2, 3, 4, 5. So the root word is pentane, and E is replaced by Al. So the second position shows the where this unsaturation or double bond is present. So it is present at second carbon. So this is pentane 2 null. Okay. Similarly, if I see the name, this is an example of a ketone. So one side of a ketone, there is a phenyl ring. Okay. So how you will do the numbering? It will be 1, 2, 3. On first, first carbon, there is a phenyl group is attached. So 1 phenyl, propane, 1 on. 1 over here in propane, 1 on denotes the position of carbonyl group. Okay. Similarly, if you look over here, this is also an aldehyde group. So the name for this will be 3-oxopentanol. Similarly, look over here. This is also a ketone. So if this is a ketone, the name is 2,4-dimethyl pentane 3 on. Okay, because at second and fourth position, if you'll see, methyl group is attached. Okay, so this will be the name. If you see over here, this is 4-nitrobenzaldehyde, or you can write it as 4-nitrobenzene carbaldehyde. And look over here, there are 3 CHO groups which is attached. So 1, 2, 3. So this is propane 1, 2, 3 tricarbaldehyde. Okay. So these are the common examples of IUPAC names of aldehydes and ketones. So if you look at this particular table of IUPAC names, okay, try to give their name as we discussed according to set of rules. Okay, so if you look over here, this is an aldehyde with 1 carbon, so the word will be methanol. Similarly, if you look over here, this is also an aldehyde group with 2 carbon atoms, so the word will be ethanol. Okay. Similarly, if I look over here, also in this case, it will be 2-methyl propanol. Okay, aldehyde group is there, and on second position, a methyl group is attached. So 2-methyl propanol. Okay, similarly, you can try the names for all the aldehydes and ketones according to the set of rules which I told you. Okay. Now there is one in-text question that we will solve. So we will solve the A part of this question, and next questions you will try by yourself. So you have to write the structures of following compounds. Okay. So let's see for the first compound. First is alpha methoxy propanoaldehyde. Okay, this is given to you. You have to write the structure. First, we will see the parent chain. So parent chain, it is prop. Prop means it contains 3 carbons in a parent chain. So there are 3 carbons in a parent chain. The functional group you see over here, suffix aldehyde. Okay, so the suffix which we are using is aldehyde. So that means there is a CHO group which is present over here. Aldehyde group is present over here. Next, the carbon atom directly attached to the aldehyde group is alpha carbon. As I told you, the carbon which is attached directly to a aldehyde group, that is a alpha carbon. So if we further look at the solution, we will talk about the substituents. So methoxy group is attached to 2 alpha carbon. If you see, it is alpha methoxy. So that means a methoxy group is attached to alpha carbon. So if I look at the structure of this compound, then you see over here, this is the structure. There are 1, 2, 3 carbon atoms, okay? And since this is an aldehyde group, so this aldehyde is used over here. And if you see at alpha position, a methoxy group is attached. So this is the structure of this particular compound, okay? So next rest examples, you try to solve it yourself according to the rules which I told you. Now we will summarize whatever we have studied in today's lecture. So this is the carbonyl compounds, okay? So this is the structure. As I told you, in case of aldehydes, this G1, it can be either hydrogen R or AR. It can be hydrogen alkyl or aryl group. And this G2 is hydrogen in case of aldehyde. So it is based on the parent acids. Suffix which we used over here is aldehydes. And for the IUPAC name, the E of alkane is replaced by Al. Like examples, ethanol and benzaldehyde. Next, we talk about ketones. In case of ketone, this G1 will be an alkyl group or an aryl group. And this G2 can also be an alkyl group or aryl group. How you write the common names? You write the name of alkyl and aryl groups according to alphabetical orders. And at last, you write the word ketone. For IUPAC name, the E of alkane is replaced by ONE. So the suffix ONE is used. Okay, like look here, it is pentane 2-on, and this is benzyl methyl ketone. Similarly, for carboxylic acid, I told you this G1, it can be a hydrogen, alkyl or aryl group, and this G2 over here will be an hydroxyl group. Okay, so the common name, it is derived from the original source. And if I talk about the IUPAC name, then E of alkane is replaced by oic. Okay, oic acid. So if look over it is formic acid, and this is benzoic acid. In case of amides, this G1 can be hydrogen R or AR group, and this G2 will be an NH2 group. So if I talk about the IUPAC name, then the suffix amide is used. So if you look over here, it is benzoamide. Okay. Next, we talked about acyl halides. In case of acyl halides, this G1 over here can be hydrogen, alkyl or aryl group, and the X will be an halogen, which can be fluorine, chlorine, bromine or iodine. For the IUPAC name, you use the suffix oil halide. Like this is ethanoyl bromide, and this is benzoyl chloride. For ester, this G1 can be alkyl or aryl group, and G2 it is OR or OAR. And the IUPAC name which we use is alkyl alkonate. So this can be ethyl butonate or ethyl benzoate. And in case of anhydride over here, the G1 can be hydrogen, alkyl or aryl group, and the G2 it is COCOH or it is OCOR or it is OCOAR. Suffix which we use for anhydride is oic anhydride. Like this is ethanoic anhydride and this is benzoic anhydride. So when you remove water molecule from two carboxylic, when you remove the water molecule in this case, then you get a anhydride. So this was it for today's lecture. And last we will talk about the structure and bonding of carbonyl compounds. It contains a C double bond O, which is the carbonyl group. The geometry is, it is a trigonal planar geometry, okay, and the bond angle is 120 degree in case of trigonal, and it is sp2 hybridized carbon which is there. Bond angle is 120 degree. If I talk about the characteristics, then it is a polar molecule, okay? It has a significant dipole moment which is present. The carbon, it is an electrophilic carbon, and the oxygen, it is a nucleophilic oxygen. And last, we will discuss about the applications. It is industrial uses, it includes in solvents, adhesives. For consumer products, like it's used in paint, fabrics, and it is used in pharmaceuticals as well, and food in field of flavoring. So this was it for today's lecture. Thank you, students. I hope you all have a good day.